Hello, everybody. I'm back. Okay, now I'm going to do a little demonstration so we can learn all about constructivist learning. So let me share my screen and head on back to let me shut off my face so my good looks don't get in the way. All right, and now we'll head to our PowerPoint. Okay, we're going to learn a bit about constructivism in education. So here are the principles. No matter what grade we're teaching, students come in through that room on the first day and they know a thing or two. We may not know what, but they do know things. We need to find out what it is. Then we can provide them with new experiences that connect to what they already know or build upon what they already know. Then the new experiences adds to their body of knowledge, and from their existing knowledge, they get new knowledge. For example, students can use things they already know to learn how to multiply by 25. Do you guys know how to multiply by 25? For instance, could you do 13 times 25 in your head? Put your pencils down. I want you to think about 13 times 25, put it on pause, and see if you come up with the right answer. 13 times 25. Welcome back. All right. Were you able to come up with that in 10 seconds or less? You should have. Here's why. We think about them in quarters. What do we have here? 13 quarters. Each quarter is worth 25 cents. And if we group them in four, we know that 13 is 12 plus 1. And we know that 12 quarters is $3. And we know that that one leftover quarter is 25 cents. So 13 quarters has a value of $3.25. So 25 times 13 equals 325. Remarkable. Let's try another one. All right. So what do we already know? Now we're getting back into constructivism. We already know the value of a quarter. And then we also already know how to determine the value of multiple quarters. And, hopefully that's something the first and second grade teachers are doing before the kids get into third grade, is showing them the value of coins. So the new experience is multiplying by 25s. So we can connect our skills of counting the value of quarters to multiplying by 25. So the new knowledge we're learning is multiplying by 25s. So we construct that concept. What's 34 times 25? See if you can do it in your head. Put me on pause. Welcome back. Well, 32 times 25, 32 quarters has a value of $8. That leaves 2 more quarters, which has a value of 50 cents. So it's 850. 34 times 25 is 850. Why do it out long if you can do it in your head more accurately? Now, how else could we have done this? Well, we could have some reference points. We know that we could, even if we only know that 4 quarters is $1, then we know 8 quarters is 2, 12 quarters is 3, 16 quarters is 4, 20 quarters is 5, 24 quarters is 6, 28 quarters is 7, and 32 quarters is 8. With 2 more quarters left over is 50 cents, so 850. Now, this might be hard for third graders, but we could do it with 6th graders. They just love it. They think it's fantastic. All right, so that's an example of constructivism. All right, we're going to be doing a lot of Singapore math in this class, the mathematics from the National Curriculum of Singapore. And basically, they say that all elementary school math concepts should start with concrete or hands-on instruction that involves the manipulation of physical objects. Then we move into the pictorial stage, where students start, instead of using the physical objects, they start drawing pictures. First, those pictures look like the concrete objects, then they look more abstract. Woo, what happened? Then finally, they move into the abstract stage of learning, where they're using numerals and operation signs to symbolize the mathematics and solve problems. And it's at that abstract stage that we want everybody, but we want them to get there by the CPA process. This is a multiplication table. There's so many patterns in a multiplication table. Look at the family of 9s, for instance. Put me on pause and see if you could come up with 5 patterns that you see in this column of 9s. Oops. Okay, put me on pause. Welcome back. Hopefully you've noticed that the 1's digits decrease by 1 each row, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And the 10's digits increase by 1 in each row, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And maybe you saw that if we add the digits, they always add up to 9. 0 and 9 is 9, 1 plus 8 is 9, 2 plus 7 is 9, 3 plus 6 is 9, 4 plus 5 is 9. And then maybe you saw that the digits, if we go in the middle, the digits are inverses of each other. 45 is the inverse of 54. Because we go 4, 5, 5, 4. Then in the next two, we have 3, 6, and 6, 3. 2, 7, 7, 2. 1, 8, 8, 1. 0, 9, 9, 0. Now that's nice if I'm telling it to you, but you need to be able to discover those things by putting me on pause. So when I tell you to put me on pause, darn it, put me on pause. All right. What does rigor in math mean? Well, it manifests itself through a cycle. We always want to start our math class with a concept that students already know. Okay. And then we teach them some skills and facts. We call that, and we want them to know those skills and facts. What the heck is going on? With automaticity. And once they know skills and facts with automaticity, we call that fluency. They take those skills and facts that they know and they apply them to problem-solving situations and they solve problems. That's called application. Then they take that new skills and facts and the problems that they just solved, and they make connections to big ideas, and that leads to new conceptual understanding. So students know skills and facts with automaticity. They apply them to problem-solving situations, and they make connections to big ideas and talk mathematically. All right, we're also going to study in this class the workshop model. In a workshop model, we have a whole class mini lesson that's directed by the teacher. That's the I do. Then there's gradual release of responsibility to the children, where students, the teachers and the students work together. That's guided practice. Then we let the kids work independently, and that's called independent practice. There needs to be some sort of assessment, and then close-in collaboration where they make those connections to the big ideas. And we're going to be doing a ton of that in this class. And that's different than traditional math, where the students did a warm-up, the teacher checks the homework, the teacher models and guides, the students do independent practice, and then they assign homework. It's not that different, but it's a little different. And these steps are also very important, but in today's classroom, administrators don't want to hear the traditions. Here's some great websites to virtual manipulatives. All right. One virtual manipulative we're going to work with is called a 10 frame. What we could do is take colored tiles or colored chips and fill in the 10 frame. If we have 2 reds and 3 yellows, we have 5 altogether. So we make a number bond. That's what this part is called up here. So we start with a 10 frame. From a 10 frame, we make a number bond. From the number bond, we make equations. So 3 parts and 2 parts make a whole of 5. A whole of 5. So we say that 3 plus 2 equals 5. 2 plus 3 equals 5. 5 minus 2 equals 3. And 5 minus 3 equals 2. So from 1 10 frame, we come up with one number bond, and one number bond produces 4 equations. Okay, interventions is something you're going to hear a lot when you become a teacher. All students, it's the goal that all students are working on grade level. If students are significantly below grade level, they need intervention. You need to be able to discuss what an intervention is in a job interview. So students significantly below grade level need intervention. In the classroom, we teach the core instruction. That's not intervention, and it should never be less than an hour. Intervention is the core plus more. And my path is one type of intervention that's electronic. But intervention needs to take place outside of the core time. And with intervention, the goal is to get students to progress more than 1 year in 1 year so they can ultimately become on grade level. All right. So hopefully you feel as though you've learned a lot through these slides. This is the end of the slide. We're wrapping it up. And I want you to think about write down 3 things that you learned today. Put me on pause and write down 3 things you learned today. Welcome back. Now put me on pause and write down what you would like to see throughout the semester in terms of my instruction to you. Put me on pause. Welcome back. Now write down what would you not like to see me doing throughout the semester. What I want you to do now is go into the slides, click on this link, which is a Jamboard, and it takes us to the Jamboard. So 3 things you learned today. Right over here is the sticky note. Click on the sticky note and write 3 things you learned today. Then that's the first slide. Go to the second slide. And write what would you like to see throughout the semester in terms of me teaching you. Go to the sticky note, leave one here somewhere. Don't put your sticky note on top of somebody else's. After you write your sticky note, it defaults to right there. But after you put it there, move it to someplace else because the next person's will be on top of yours and I won't be able to see it. And then in the third slide, what would you not like to see throughout this semester? All right, hopefully that was enjoyable for you. Now let me just go back to January 23rd because I'm going to make a new slide video to tell you about the homework that you need to do.